I'm going to be posting 2 videos on evaluation of assurances and annuities section from the topic of contingencies in actuarial maths. And this first video is going to deal with a lot of the approximations and formulae that you need to know that relate annuities to each other. And then the second video, and that's including, for example, the premium conversion formulae. And then in the second video, I'll be covering annuities payable pthly or mthly for life annuities, of course. Okay, so this first video, I'm also going to be explaining as much of the understanding behind these formulae as possible. So let's start with the first thing. A lot of this, maybe not a lot, but some of this I've already covered in previous videos. So if I don't give it too much explanation, refer to the videos that I've already filmed. But I'm still going to include them here anyway because it doesn't harm to see it twice. Okay, so first thing is AX is equal to AX plus 1. The reason for this is a whole life annuity payable in advance. That's payable in arrears. And so the only difference here, they both stop payments on the death of a life that's now aged X. And the only difference is that this one pays an immediate payment at the start of this first year. And so in order to equate the two, I have to add that payment to the one that has payments in arrears. Okay, next I have a temporary annuity payable in advance to a life aged X with a term of n years, and that is equal to another temporary annuity but payable in arrears for a term of n minus 1 years to a life aged X. And this, if I add 1, it equals to this. So why is this the case? Well, same reason I'm adding 1 for this first formula, I must add 1 here. But the difference is now that this one has a decreased payment of n minus 1. It means I'm knocking off that last year where this would normally be paying at the end of the year. I'm just saying that in that second to last year of this one, or in the last year of this annuity, it's paid at the start of the year, which would be the second to last payment of AXN. But now, because I use n minus 1 instead of n, I'm basically knocking off that nth payment, that last payment, and I'm adding on a 1 for the first payment, so they still have n payments on the right and left hand side. So now the cash flows match. Okay, then I have AX, whole life annuity to a life aged X in arrears. This relates V times by PX times by AX plus 1. So this is a whole life annuity to a life aged X plus 1, but payable in advance. So it starts paying at age X plus 1. This one also starts paying at age X plus 1 because it pays at the end of year X. And so the only difference is this, I have to discount by a further year in terms of time and probability in order for it to equal to this left-hand side. Okay, then I have similar situation except with temporary annuities. Okay, so this is a temporary annuity in arrears for n years. This is a temporary annuity to a life age X plus 1 now instead of age X for n years. Okay, now the difference here is they're both paying n payments. Okay, so that's matching, that's fine. But this starts at age X plus 1, but it's in advance. This starts at age X, but it's in arrears. So effectively the first payment here is at age X plus 1. So the payments do match, but the difference is the same as in this case, where the payments, this one is discounting them to time 1 or to age X plus 1, but this is discounting them to time 0 or age X. And so we have to discount this by a further year in terms of time, value of money, and probability in order for it to equal to the left-hand side. Okay, then a lot of these annuity approximations. So first of all, continuously payable temporary annuity is equal to a temporary annuity paid in arrears minus 1 over 2 into 1 minus v to the n npx this should actually be more like that, okay? Then I have AXN is equal to AXN minus 1 plus V to the N NPX. Now, I could have done minus 1 into negative. It doesn't really make a difference. Okay, so why have I done this? This one's more intuitive. So first of all, I subtract the 1, this first payment, in order for the payments to match here. I need to subtract off that first payment, but then I need to add the last payment that's happening here. Okay, so if I'm adding the last payment that's happening here, then the last payment happens at time n, but I first have to get there. So I have to discount in terms of time value of money and in terms of probability in order to add it back so that I can relate to that payment. The last payment of this annuity on the left-hand side. Okay, so this really helps us understand this previous formula. Now, in the life annuities videos, it was either part 1 or 2, I can't remember, I tried to explain this formula, admittedly rather unsuccessfully, but this explains it quite a lot better. So if you were confused there, this should help you quite a lot. So let me explain what I'm meaning, and then I can try and explain to you why this makes sense. Okay, so first of all, we understand how this formula works. Now, how does this work except without the temporary part, without the term part? So I would have AX is roughly equal to a dot dot x minus a half. Okay, so this works because here I'm effectively having the same number of payments as here in terms of a unit of payment, in the sense that, yes, this is payable continuously, so we're not strictly talking about number of payments, but in each year I'll have 1 unit worth of payments that are happening and 1 unit worth of payments that are happening. But here, when the person dies, they're not going to be receiving that next payment, or they would have received still the payment for the rest of the year. And we're going to assume that they're going to die in the middle of the year. So they receive that payment for that year up front at the start, that unit payment. But here, when they die, it stops paying immediately on death. And so they're missing out on that half a payment at the end of the year. And so to equate these, I have to decrease the size of these payments by a half. Okay, that's the understanding for this one. Now, that helps us understand this, where now I must subtract 1. That helps us understand this here, where if I distribute this negative a half, I get minus a half plus a half into that. Now, if I use the interpretation of those two, I can then understand that top formula. Okay, so I first subtract the half for the same reason that I'm subtracting a half here, because of this, or essentially rather because of the first payment that's happening, same reason that I subtract the 1 there, except I'm subtracting a half because it's not fully switching from start of the year to end of the year. It's switching from beginning of the year to continuously payable, so I subtract the half. And then here, I need to add this half for the end of the term, similarly to for the reason why I need to add that payment at the end of that term. Okay, so hopefully those two things clear up this explanation quite a lot more. That's what I'm hoping. Okay, if it's unclear, leave a comment, and I'll try my best to maybe rephrase it. But it is something that's just difficult to understand in the first place. So I really recommend you just learn these formulae. We're not necessarily going to get tested on the direct understanding of these particular formulae, but it is something that you need to know, the formulae, and you need to know how to use them, and that's important more so than being able to explain why you add and subtract halves. It could be something that you're asked to prove, but still not explain it. Okay, but anyways, the explanation is supposed to help with the memory of why these formulae work. Okay, so next I have a continuously payable temporary annuity, which approximately equals an annuity in arrears now, not an annuity in advance. Temporary annuity plus a half into 1 minus v to the n npx. Okay, if you use these two formulae, you can arrive at this third formula over here. Okay, now I'm going to talk about the premium conversion formulae. So these are the formulae of this form. AX equals to 1 minus D to the AX. Okay, now this in its form right here is not very intuitive. The intuitive way to understand this is as such. Okay, now why is this intuitive? Well, this is intuitive because essentially this is an annuity for a term of the complete future lifetime, and this equals to, we know the formula, v to the tx over d, but now I'm just taking the expectations of both sides. Now the expectation of the left-hand side equals to this. This is just the actuarial notation for the expected present value. Now the right-hand side, when I take my expectation on a linear combination of my random variable, then the expectation acts in a linear way, and so this one comes out just the way it is because it's a constant. This coefficient of negative 1 over d comes out just the way it is with a negative 1 over d, and so essentially this expectation moves up here as such. And now the expectation of v to the tx is the definition for this actuarial notation for a life assurance contract, a whole life assurance. Okay, so this is much more intuitive because it takes the form of these certain annuities that we know, and so I recommend you just memorize them this way, and this is the way that we relate annuities to assurances. Okay, let's move that up here. Then we also have the same rule applying for term assurances and temporary annuities. Now please note that for this temporary annuity, it needs to be in advance. These ones, they need to be in advance, not in arrears. Okay, and also, by the way, these both hold if you're dealing with select mortality as well. So in other words, if you have square brackets around your ages, those equalities still hold. Okay. Then we have the same general rule applying for continuously payable annuities relating to assurances that are payable immediately on death. So this is the intuitive way to think about it, which just relates to a bar x equals to 1 minus small a bar x times by delta. Okay, where delta is the force of interest here. Okay, then this also holds for the temporary continuously payable annuities and assurances, term assurances paid immediately on death. And once again, this holds for select and ultimate mortality. So you can just add your square brackets to the ages and those work just fine. Okay, so this is a relatively short video compared to all the other videos in this series. And in the next one, I'm covering annuities payable mthly. So stick around for that.